Hello ladies and gentlemen, welcome to my video. Today's question is pretty interesting. We first convert the equation become double integral. Along the way, we use the concept of geometry series to solve part of the integration, and we get the answer by Wallis products for pi. We know that differentiate of x power y over dy equals to natural log x multiply x power y. Therefore, integral x power y dy must be equals to x power y divided by natural log x. In the case that integration bounds are from y equals to 0 until y equals to 1, that gives us the result equals to x minus 1 divided by natural log x. We can replace this result into question Q. Therefore, Q equals to integral x equal to 0, x equals to 1, integral y equals to 0 to y equals to 1, x power y divided by x plus 1 and then dy dx. It is unlogical to solve the dy because once we solve the dy, the equation goes back to the original Q. Therefore, it's better we swap the dy and dx. Of course, we need to swap the respective integral for x and y as well. Consider part of the integrand 1 divided by 1 plus x can be rewritten as 1 divided by 1 minus negative x, which is equals to a divided by 1 minus r, where a is the first term of a geometric series equals to 1 in this case, while r equals to the common ratio, which is negative x. From the integration bound, we notice that x is between 0 to 1, which is fulfilling the condition of a geometric series, which means we can rewrite 1 divided by 1 plus x as a geometry series, which is equals to 1 minus x plus x power 2 minus x power 3 plus x power 4 and so on, which is equals to summation of k equals to 0 until infinity negative 1 power k multiply x power k. We can put this back into Q. That gives us Q equals to integral y equals to 0 until y equals to 1, integral x equal to 0 until x equals to 1, summation k from 0 until infinity, negative 1 power k, x power y, dx, dy. Let's bring the summation for k equals to 0 until infinity for the negative 1 power k out, while the double integral symbol remains the same there. Meanwhile, the integrands become x power k plus y, and then dx dy. Focus on the j. After integral for dx, j equals to x power k plus y plus 1 divided by k plus y plus 1 for x equals to 0 and x equals to 1. Put in the value, we have 1 divided by y plus k plus 1. Put it back to the equation Q. This is what we have. Summation k equals to 0 until infinity, negative 1 power k, integral y equals to 0 until y equals to 1, 1 divided by y plus k plus 1 and then dy, which gives us q equals to summation k equals to 0 until infinity, negative 1 power k, and then natural log y plus k plus 1 for y equals to 0 until y equals to 1. The summation term will be still there. We have a natural log k plus 2 minus natural log k plus 1. We can combine using natural log rules, become natural log of k plus 2 divided by k plus 1. Let's put in the value of k from 0 until infinity. When k equals to 0, negative 1 power 0 equals to 1. When k equals to 1, negative 1 power 1 equals to negative 1, which means the negative 1 power k determine the sign of the terms positive and negative came out alternatively, such as positive natural log 2 divided by 1, and then negative natural log 3 divided by 2, and then positive natural log 4 divided by 3, and then negative natural log 5 divided by 4, and then positive natural log 6 divided by 5, and then negative natural log 7 divided by 6, and so on. We can change negative log become positive by inverse the value inside. That gives us natural log 2 over 1 plus natural log 2 over 3 plus natural log 4 over 3 plus natural log 4 over 5 plus natural log 6 over 5 plus natural log 6 over 7 and so on and so on, which is equals to natural log, and then the numerator is 2 multiply 2 multiply 4 multiply 4 multiply 6 multiply 6 and so on and so on, while denominator is 1 multiply 3 multiply 3 multiply 5 multiply 5 and so on and so on. Here we are going to use Wallis product equation for pi. This is the equation. It is pi over 2 equals to a product equation defined by Wallis. Don't worry if you do not understand the equation because we don't need them. What we need to know is to convert the Wallis product equation into numbers, which is pi divided by 2 equals to numerator is 2 multiply 2 multiply 4 multiply 4 multiply 6 multiply 6 multiply 8 multiply 8 and so on, while denominator is 1 multiply 3 multiply 3 multiply 5 multiply 5 multiply 7 multiply 7 and so on, which means this equation is exactly replaceable into our equation Q. That brings us to the conclusion of this video. The final answer of this question is equals to natural log pi over 2. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video in your social media. See you tomorrow for more video. Bye bye.